All right, guys. So today we're going to start comparing exponential functions. We just spent the last several days comparing linear functions, so now we're going to move on to our exponentials. So remember, an exponential function is a function whose value is a constant raised to a power of a variable. What that really means is the variable in an exponential function is in the exponent. So when we were learning how to determine which equation was which when we were looking at comparing functions, the one with the variable in the exponent was always the function, the exponential function. So every time your x is going to be in the exponent. And sometimes we use n, so your variable will be in the exponent. These are some of the different forms that we used throughout the year when we were learning about our exponential functions. We had our parent graph, which was the most basic of the exponential functions. This one takes the parent graph, b to the x, and adds transformations. Remember your stretch and your shrink and your asymptote and your left and right and all that. Then we had our sequences formulas and the exponential form. So overall, what's real important is there's several of these important comparison points that we use when we're comparing exponential functions. Rate of change is a really big important one. So rate of change, there's a couple ways it can be asked for. You could be given a table with no interval, and that's asking for the overall rate of change. Okay, and you're looking for what is the common multiplication pattern for the overall rate of change of the entire function. That's if you're given a table with no interval or anything. But sometimes you're given a table with an interval. And remember, that looks like you could be given this and you'd have a number and a number. And those are x values. Okay. What you'll want to do is look in the table of value for these two x values to find the y values to get your 2 points. Plug it into the slope formula. The other way this could work is you could actually be given a graph with these 2 points. You could look for the x values there. Or an equation where, and then the equation, the base number next to the exponent, that's your rate. So here, this number right next to the exponent, that's your rate of change right there for overall. Okay, rate of change. All of those are your rate of changes. Okay, x-intercept, remember that's where the graph crosses or touches the x-axis. That's where your y value is 0. We're not going to use that as much. Really, we're going to focus more on the y-intercept, the rate of change in y-intercept, and for a given x value. So your y-intercept is where the graph crosses or touches the y-axis. It's where your x value is 0. So when you're looking at a table of values, you can go to where x is 0. If you have an equation, you can plug in x is 0 and solve for the y. And when it's the graph, you go to where the y-axis, which is where x is 0, to find where the graph crosses. And the final way we're going to talk about is for a given x value. So I would say x equals some number when it's that. So if you have an equation, you're going to plug that x value into the equation and solve for the y. And that'll give you the point. For the table, look for the given x value, and then you'll see your y value that goes with it. For the graph, follow the x-axis to the given x value, and then you move up or down to the graph, and that will help you find your y value. So let's try some examples to get you started. The first one, I have 2 graphs here, and I'm asking for the greater y-intercept. So I want to know which y-intercept is a bigger number. So I have 2 y-intercepts because I have 2 graphs. I have the f of x y-intercept is at -1, and the g of x y-intercept is at -5. Now, how do these two relate to each other? At -1 is greater than -5 because it's closer to 0, it's less negative. All right, so if I want the greater one, f of x is going to be my greater y-intercept. So hopefully this is coming back to you some from our linear comparisons. We use a lot of the same ideas. So for number 2, I want to know which exponential function has a greater rate of change over a particular interval. Remember, these intervals are x values, and you're looking for the corresponding y values. So for my f of x function, if x is 1, my y value is 10, so I have a point of 1, 10. And if my x value is 2, I have a y value of 20, so 2 comma 20. I'm going to plug these into the slope formula. y2 minus y1 over x2 minus x1 gives me 10 over 1, which is 10. I remember we talk about absolute values when we're talking about rate of change. And so the absolute value of 10 is still 10. Let's take a look at g of x. If your x value is 1, you have a y value of negative 16. And if your x value is 2, you have a y value of negative 32. Let's plug this into the slope formula. y2 minus y1 divided by x2 minus x1. Remember, if you have a minus minus, that's going to turn into a plus. So you get negative 16 over 1, which is negative 16, and the absolute value of that is 16. Now, which one of those is the greater rate of change? 16 is a bigger number in the comparison. So g of x has the greater rate of change, given those two exponential functions. All right, let's go ahead and try on the back. Number 3, I'm giving you 2 equations, and I'm asking you a couple different questions here. First, I want to know which exponential function has a smaller value when x equals 2. So what they want you to do is they want you to plug that number in for x. So they're saying if f of x, if x is 2, you're going to have 2 squared plus 5. Well, 2 squared is 4 plus 5 equals 9. So if x is 2, y is 9. Let's find out for the other. We want to plug in 2 here. So we have 3 squared minus 2. 3 squared is 9 minus 2 is 7. So if your x is 2, your y is 7. And I want to know who has the smaller value when x is 2. 7 is less than 9. So g of x has the smaller value when x is 2. The second question asks which exponential function has a greater overall rate of change. Overall rate of change is the number right next to the exponent. So this function is changing by multiplying by 2 each time. This function is multiplying by 3 each time. So we have a rate of change of 2 and a rate of change of 3. No, sorry, I wrote that backwards. 2 is less than 3, but I want the greater, so that's 3. So g of x has the greater rate of change overall for these functions. So now let's compare this graph and this table. We're going to use the following exponential functions to answer these 2 questions. Again, I have a specific when x equals number and over an interval number. So when x equals 3, so I'm going to follow the x-axis to where x is 3, which is right there, and I'm going to move up or down to hit the graph. Well, in this case, I got to move up, and it looks like, to me, that's where the 3 intersects, and the name of that point would be 3, 6. So when x is 3, the y value is 6. If I look on the table, when x is 3, the y value is 8. 6 is less than 8, but I want the greater value, which is 8, which means g of x has the greater value of those 2 functions at 3. And it can change. It depends on which particular x value I'm asking about. Let's look at B. Which exponential function has a slower rate of change over the interval 0, 2? So this is going to be the lower number is really what it's asking. So if we're talking about f of x, if x is 0, y is going to be negative 1 to be on the graph. And if x is 2, we're going to go to 2, y is going to be 2 to be on the graph. So we're going to do y2 minus y1 over x2 minus x1. So we got 2 plus 1, which is 3, and 2 minus 0 is 2. So this answer is 3 over 2. It might help you to think about this when we're coming into fractions. If you do 3 divided by 2, you get 1.5. So I've got a rate of change of 1.5. It kind of helps me get a number. Let's see what g of x looks like. So g of x is if my x value is 0, my y value is 1. If my x value is 2, my y value is 4. Plug this into the slope formula. y2 minus y1 over x2 minus x1 gives me 3 over 2, which is 1.5. These guys actually are the same. One is not bigger than the other. They're both the same. That happens sometimes. And it's not a big deal. You just want to check to make sure. All right. And our last example. Which exponential function has the smaller value for the y-intercept? So the y-intercept, I have the graph. That's nice. I can see it right away. The y-intercept here is -3 for the f of x. For g of x, I'm going to have to plug in. If I want to find the y-intercept, remember I'm actually plugging 0 in for x. So 0 plus 3 is 3. 2 to the third is 8, minus 1 is 7. So if I want to know who has a smaller value, f of x has the smaller value for the y-intercept. If we could see the graph, it would have crossed at -3. And our final example, which exponential function has a greater rate of change over this particular interval? All right, so let's pick out our points. For f of x, if x is -3, right here, it looks like y is 4. If x is 0, y is -3. And then we're going to run our slope formula here. -3 minus 4 over 0 minus -3, which becomes plus. So we get -7 over 3. So if we want to know a decimal, sometimes it helps us to compare with decimals. I get -2.3, just to give me an idea of what my slope is as a decimal, so I can make a comparison to the other. So now my equation, I can either plug in -3 and 0. We actually already know if x is 0, y is 7, because we did that already right here. If x is -3, what I want to do is I'm going to take my equation and I'm going to say 2 raised. My x is supposed to be a -3, so I'm going to say -3 plus 3. And I'm going to arrow right to get it drop back down and say -1. And I get 0. Okay. Now let's do some math. And I have 0 minus 7 over -3 minus 0. And I get -7 over -3, which is +7 over 3. Now remember, we're talking rate of change. So we're talking this absolute value here. And these actually have the same absolute value of 2.3. So their rate of change is the same over that particular interval. It might not be over another interval, but at that interval they are. All right, so after you finish the notes, tomorrow you can work on the practice, and then there'll be a 10-question quick check for the next day. Please let me know if you have any questions. Talk to you later.